Hello, this is the fourth video of the Calculus 1 series on improper integrals for OCR Pure Core Further Mathematics, and it looks at integrals that cross a value where the function is undefined. In this example, where f of x equals 1 over x minus 1 all squared, we can see that the function is not defined at x equals 1, which lies within the limits of the integral, these being 0 and 3. The technique we will use here is to split the integral at the problem value, i.e. x equals 1, and look at integrals between 0 to 1 and 1 to 3 by introducing a new variable a, which will tend to the limit of 1 in both split integrals. So just writing in that function then, you can see what we mean by those split integrals between 0 and a new variable a, and then a up to 3. In this case we have chosen that limit a tending to 1 as that's the problem value. It's important to keep these separate. So the integral will be 1 minus 1 over x minus 1 So when we put those values in, we get these two integral results. Being careful with our negatives there. Now 1 over a minus 1 is undefined as a tends to 1. So therefore it looks like both those integrals will diverge. So it is important to keep those integrals split and that as neither of them converge, we can say that the overall integral diverges. Here's a second example where y equals x to the minus 1 to the minus 2/3. When we write that y equals 1 over, in this case it'll be cube root of x minus 1 squared, then we can see that it is not defined at the value x equals 1, which lies within the limits of the integral 0 and 4. We'll use the same technique as previously. So it's still the limit as the new variable tending to 1. I'll write it on a different line here. In this case the upper limit's 4. And when we investigate that, that's going to integrate to 3x minus 1 to the 1/3 . I'll leave that as -1 for the moment. There we go. Okay, so we're going to consider what happens as a tends to 1. Well, we can see that in that case, a -1 will tend to 0. And so therefore, we will be able to state an integral value, which will be 3 plus 3 cube root of 3. So, because both of the split integrals converge to a value each, then the overall integral can be evaluated and will be convergent. So to summarise the technique, we've split the integral at the problem value d in the range for x, b, c, and replaced it with a variable. We've called that a. And then we've looked at what happens in the limit as the variable tends to the problem value. If the value of the split integrals do not converge, then the integral overall diverges. Otherwise, it converges and can be evaluated. This is the last video in the Calculus 1 Improper Integrals series.